Welcome to Free Text and Natural Language Processing. My name is Wuraola Oyewusi, and this is AI Saturdays Lagos. I've already said it's nice to be here, and welcome to class. I hope you participate. So natural language processing is a collective term referring to automatic computation of human languages. So every time you hear natural language processing, we are dealing with human languages. And of course, they include algorithms that can take human-produced text as input and algorithms that produce natural-looking text as output. This is still about text, but every time you hear natural language processing, it's usually, we're talking about either speech or text. Our focus today is on text. I am a text person. Okay, this is another definition. This is from Wikipedia. And the interesting thing is that I think I copied this from Wikipedia the last time I taught this class. I put their new definition. Okay, this is 2020. It wasn't in this class. So natural language processing is a subfield of linguistics, computer science, information engineering, and artificial intelligence concerned with interaction between computer and human languages. In particular, how to program computers to process and analyze large amount of natural language data. It went ahead to list some of the uses of natural language processing. So this is a more robust definition because it brings the perspective of NLP, natural language processing, being different people work in NLP. So some people who work with NLP, they could be people called computational linguists. So linguists work here a lot. If you have a background in language, you may enjoy this. Definitely people in computer science, people that have interest in artificial intelligence, anyone who is curious about how computers and humans interact. And then the last one. And then, okay, so this says natural language processing is an interdisciplinary subfield of computer science and linguistics. So the Wikipedia definition has changed a bit. This is after 3 years, I put the date. It involves processing natural language data sets, such as text corpora or speech corpora. Every time you see corpora or corpus, most times it's a body of text. Like it could be a lot of documents, but it's a popular term that it makes sense. And I should let you know that using either rule-based or probabilistic machine learning approaches, I should let you know that there are, while quite a number of NLP techniques are machine learning based, every time you think about machine learning, know that people have attempted to do those things with rule-based systems. And you should know that they work. It's I usually try to give the context that machine learning is an interesting technique, but it's built on quite a whole lot of other things, and some of them worked just fine. They may not be able to scale, they may not be able to do transfer learning, but many of them worked. And whatever work we have now is built on years and years of research. So the goal is for the computer to understand the context of documents, including the contextual nuances of the language within them. And this is a very difficult problem. How do you teach machines to understand context? So NLP technologies can accurately extract information and insights contained in documents. This is also focusing on document, but like I said, remember I said typically when you're talking about NLP, you're talking about text and speech. Okay, so our business for today is free text. This is one of my favorite authors. Dipanja says, text data usually consists of documents which can represent words, sentences, or even paragraphs of free-flowing text. So our class today, I know I've mentioned, when you're thinking of NLP, typically you're thinking of speech and text, but our focus today is on text. So, and it's known not to be structured. They are not typically written in data columns. They can be noisy. They are the things we write on Twitter. I code mix a lot. I'm probably writing English with some Yoruba or Pidgin. Those are all the persecution you will face when you're working with text, which is interesting. And it makes it difficult for machine learning to learn on. But we are in an interesting time right now. Okay, so I wanted us to look at this together. We're going to use one of the popular chatbots, OpenAI chat system. I wanted us to look at how big is text data. Why is it important that you pay attention to text data too? I'm sure throughout this lesson, you've been working through different things. Some people work with numbers. Some people, maybe at work, you work with numbers. What can you do with the text data at work? What can you do if you're a researcher and you're working with text? What can you do? How big is text and why should you pay attention to text data? So I'm gonna stop sharing this. I've already opened the chat window and I was thinking we could look at it together. And another reason why we are doing this is that chatbots like ChatGPT, like we are going to use now, they're like the state of the art of what is going. This is many people's first attempt of just texting. This is what they are going to do. And I'm going to tie our lesson back to how we got here, which was not it wasn't happening like that when I taught this class in 2019. It wasn't this publicly available to be able to query chat interfaces. So this is OpenAI. If you want to do it on you probably have these or something similar or bad, whatever chat system. And our goal is for us to look at how powerful is text data, what proportion of internet data is, what proportion of internet data is text? Why is it so important? What are the sources of text data? So I was thinking we can look at it together if you don't mind. So, okay, so the question that we want to ask, let's find out together, how big is text data on the internet? So let's ask directly. So this is one of the ways most people, even if you're not a professional, work with text data. And as at 2019, if you wanted to ask a question like this, you will use a search engine, maybe just normal Google or Bing. But now this is one of the places people check for information. So this is my question. Of course, it's not. It said, ChatGPT says it's challenging to provide an exact size for the entirety of text data on the internet. But it says that it's sure that it's constantly growing and it changes. And then it puts that this is where my knowledge stopped though, as at September 2021. So I'm going to mention things like this, our systems like this trained at the end. So it shared some of the sources of text data, the web pages, social media, like I said. You and I are contributors to this type of data. As I'm speaking here, as you're listening to me, you're contributing to these blogs and articles, databases and archive, messaging services. So even if you're offline, you are probably generating text data somehow. Even if you say, me, I don't used to do social media. I know people say things like that, but you're probably on WhatsApp, you're probably writing text. So text data is everywhere. Let's ask, what is the estimated proportion of text business data? Of business data that is text. Why we are doing this is that to give you a perspective, depending on what you do at work, depending on how you are setting your ambition. I understand that for some people, this is their first encounter trying to learn AI. For some people, they already have a career, they are thinking about to incorporate this. But this is how big. Typically, the top level percentage that is usually claimed is that between 80 to 90% of business data is usually text. So ChatGPT is trying not to say this is the percentage, but these are some of the documents at work you may want to process with text data. You may want to process with NLP. There are email communications if you work in marketing. You may, for some systems, you don't need to reinvent the wheel, but for some, you may be working in a system where ecosystem is closed. They don't want their data to interact with standardized tool, yet they want to use AI, they want to process their text. So when you're thinking of scenarios like this, as a data scientist, as an ML scientist, or whatever you are aiming to become, it's one of the reasons you should pay attention to text data. You could be working in maybe a legal or an health system where, even though there are APIs that they can consume, they don't want to consume those APIs. They want to build their system from scratch for different reasons, for privacy, for things like that. So these are some of the things you will come across in your work: data text, customer communication. I know quite a number of workplaces, they want to implement their own chatbots. For some systems, the language that you want your chatbot to work in is not the language of what is readily available. So I'm making a case for why you should pay attention to text data. It's already a big part of the data. And for people in places where maybe you're trying to prove a point, you want to say, this is my contribution to this department. Let's find more insight from text data. So it could be from your emails, it could be from business documents, it could be from financial reports. Text data is everywhere. It's just you've probably not been paying attention. Maybe you've been working with numerics, you've been working with numbers, but it's everywhere. It's in your life, it's on social media. The team wants to know what people are saying about them in social media. Sometimes they want to do data mining. How is our products being mentioned? You're the scientist on the group. And so yeah, I was guessing. Let me see if I can prove this further. So NLP technologies are here. This interface that I'm sharing with you is one of the victory of NLP technologies. I understand there are questions about the answer is given. Is it hallucinating? Should you trust it? But that's not what we are discussing right now. We are discussing the technology behind it. Let me ask ChatGPT, can you provide an estimated percentage of business data that is text? Or let me do textual to sound more English. Okay. Okay, so now that I've changed, I've refined my prompt, it's similar output, but now it's saying that some estimates suggest that unstructured textual data may represent up to 80 to 90% of all data within an organization. Of course, if you are quoting these maybe in your research or something, you should definitely deep dive and actually have a source for this. But now that I've probed the ChatGPT for that, and then of course it returned some of the previous responses that, okay, they said that these are some of the industries that you use text, healthcare. I assume everybody in this class is from different industries or they are aiming at different things. But so so in this session, we've looked together what text may be like. And like I said, the general estimate is that unstructured data, such as text, is usually up to 80 to 90% of all data. So let's say you are leading a team at work. I understand that we have a mix of audience here. The team says that we have beginners, intermediate, and experienced people. So some of you, I believe you are decision makers at work. Let's say all the insight that the team has been deriving is from numbers. It's time to look at text data too. It's time to look at, what can you do with text data in all these industries? And when you think about things like this as a data scientist, as a future AI engineer, I don't want to think of them just in terms of, I'm an advocate of using what is readily available, but sometimes you'll be in systems where they want their data in silos, and you will have to think of how to design things like this from scratch. And I know that's part of the team is working at, they are putting labs, they are putting this for you to be competent at things like this. So, okay, now we've made a case for why text data is important. So now let's dive in. So let's go back to our slides. Okay, so we have an idea of how big text data is. We have an idea of a bit of how to prompt systems like ChatGPT. There are other ones like that, depending on whichever one you're using. And like we found that after probing a bit further, that up to 80 to 90% of the business data, research data that you could be working with, or you could have been letting slide in your team, is text data. And that's why you should pay attention. So there are different applications of natural language processing. And the interesting thing is that when I made this particular slide, maybe it was about 3 years ago, and the first thing there is still natural language generation. But the cool thing is that it's what we just did on the interface right now, prompting and generating some text. The technology that was available to do something like that as at the time that I made this slide, you should know that, I know that I made the fundamental that these things, they didn't just come out of thin air. It's years and years of research. So, okay, let's just list them depending on what you may like. These are some of the ways natural language processing is in action: language generation, speech recognition, speech sentences, ontology population for people who work with databases and knowledge graphs and things like that, question answering systems, machine translation. You've probably used this before. You've used Google Translate. That's NLP in action. Search engines. Search engines, I understand that people talk about adverts and all that, but it's amazing the type of things that we have access to: text coherence, fake news detection, sentiment analysis, basic text classification, named entity recognition. These are all applications of natural language processing. So let's go to the next slide. So typically, as an NLP person, these are some of the common tasks that you probably do. Tokenization. If I don't want to sound absolute, I understand that some people consume NLP APIs and you don't understand what goes on behind the hood. But it makes sense, especially if you use this tool to understand the fundamentals. So typically, these are some things that, let's say we were teaching a class from scratch. These are some fundamentals of what you want to know what is happening. You don't want to be the type of AI scientist or an ML engineer who is just top level. You don't know why what you're consuming is doing what it does. I understand that maybe you can make money. I'm not saying that a team will not recruit you, but you want to be that person that understands exactly what goes on behind the hood. So these are some things that goes on behind the hood. There's tokenization, sentence boundary detection. You do things like part of speech tagging. I know that for things, for basic things like this, many people don't pay attention exactly what is going on behind the hood, but it's one of the great things that machine learning has enabled people to do. Typically, to do things like part of speech tagging is usually rule-based, and then you look at the system, you try to extract it, you label, then you try to set a rule that if this thing is at the beginning of the statement, it's probably a preposition and things like that. But it's one of the cool things about machine learning, where you pick a sample data set, you train, you label for those things that you want, and then you apply it to new data. It's amazing. I've not done selectional preference before. I've done part of speech tagging. But if selectional preference means maybe selecting a particular entity, I've done that. Now, phrase chunking, it's typically a task you do with things like part of speech tagging. And then semantics, you can do sentiment. Many people have done sentiment analysis and opinion mining. It's a popular task. It makes sense for people to learn that because sometimes it's a low-hanging fruit. Like you can pitch to your team, how are they talking about us on Twitter? Can we do sentiment analysis of what our products are like? Before it was easier to have access to Twitter API, and it's usually an interesting task for people just beginning. I don't know how easy it is to get the key and stuff right now, but before, or for a task like this, you have a task to go scrape some data on Twitter. That's how you learn how to scrape data. And then you do your first sentiment analysis. Behind the hood of a task like sentiment analysis and opinion mining, it's still a type of a text classification task. When you're setting things like that up, you label your data for the analysis, or if it is a positive, negative, or neutral. Sometimes you assign scores and things like that. It makes sense. It's an interesting task, and it's usually a good place to start. Let's say after this class. I should mention that I understand that I think this is class 8, but for you to be a great ML engineer, I totally expect you to be learning more than what is being taught in class. So this is a good task. If you can note it, try to do something with sentiment analysis, and I encourage you to read the theory. I encourage you to attempt to label your own data. The emails that come in at work, let's say you're a senior, can you tokenize them? Can you try to decide the tone of an email by labeling some of your data sets? It's a good way to get started at NLP, and it's a nice thing to do if you have the time. Yeah, and then named entity recognition. Named entity recognition is typically if there's a body of text, what are the most important things you want to find? Personally, I've used this for different things. I've used it in healthcare. Let's say there are reviews online. Let's say there are reviews. People are discussing about their medication or their disease on open discussion channels like maybe NairaLand or Twitter. One of the things you can use things like named entity recognition for is, let's say you work in a pharmaceutical company. Imagine if it's your brand that they keep mentioning that it's giving adverse drug reaction. It's giving adverse drug reaction. Or let's say you work in a financial institution, which I think quite a number of people work in Nigeria. It's you people that on social media, everybody keeps saying, your ATM is not working. They've caused the team. This is one of the ways you can train an ML model using named entity recognition, at least to even find your name first. Before you even figure out that they're cursing out the team, do people have a recurrent problem? There was a time Twitter was nicer that you could have exactly where the tweet was coming from, not just what people put in their profile. It can give an idea of is it like the coverage of our services? Is it like in this zone? But this is an important task, and it makes sense for you to be able to. Sometimes, of course, there are pre-made NER models that can find basic things like a person, the name of an organization. A good system will know the difference between where this type of system may get complicated, where it makes sense for you to know how to do things like this. For example, there are prominent names all over the world. In Nigeria, it could be slightly different because the company name, it could just be your family name, like Ogundepo and Sons or Ikechukwu and Sons. Organizations are not exact. Organizations are named and Sons, maybe in England too, but a pre-made system may not be able to see that. But if your business data, you're working with people, let's say you're Coca-Cola or something now, and then they have all these, I know that, FCMGs in Nigeria, don't let me mention a specific name. Sometimes you put names of businesses. The business name could be Yatope and Sons. It could be Yawura and Sons. If you build a good system as an AI engineer, an NLP engineer, or whatever you are at work, you want a system that can see those names. So I'm not making a case for just what you should do theoretically. I'm trying to tie it to your deliverables as much as possible. Or let's say you're trying to figure out addresses in text data and it's all modeled up. You can use, you can train your own NER model to find names that are important to you. In pre-made models, there are, let's say we just want to do a task. I can bring out the text, and then the pre-trained model, maybe from Spacey or from whatever system that you're using, we'll try to find the basics, but depending on the extent of your problem and what you're trying to solve at work, I encourage you to understand how this works. Label your own data and find the names you're looking for. Sometimes, entity linking is close to named entity recognition. Typically, what you're doing that is that, for example, I'm using NER to find names of medication or names of disease or names of disease in a particular text type, depending, I don't know where it came from, wherever it came from, real patient case notes, online places where people discuss their issues anonymously, your research data, wherever, you may want to tie them to established databases. So at least for healthcare, I know there are established databases of, let's say, medication, there's the name that is used to name across. So you want to link it to your database. So depending on your business, like I said, let's say you're working in places related to addresses, and like I mentioned, the names of addresses, it may not be what is. So if you're linking your entities, or let's say you're working in a business where you've recognized some entities and you want to link it to a database like maybe PVN or name or things like that. I don't know where you work. I don't know where you're going to work, but I'm trying to let you know that there are NLP techniques that can improve your work. Named entity recognition is part of information extraction. Sometimes what you're looking for is just one thing and it's simpler. And then there's topic modeling. The fastest way to explain topic modeling is on Twitter. Sometimes it brings you similar topics. What powers that is topic modeling. When you see it in action, it doesn't look like a big deal. Like, oh, maybe I started, I was talking about Teju, or I was saying, oh, Teju, and something, and then somebody else is mentioning Teju and is in relation to AI Saturdays Lagos. Somehow you will find that those tweets come to you together, and then you are saying, oh, this was what happened, where I mentioned Teju's name, AI Saturdays Lagos are running classes. When you think of it in action and you see it on your phone, it doesn't look like a big deal. But every time you think about this data set, I want you to think of scale. For data that is not a lot, I can sit down and do it if it's just a few pages. But the number of tweets going out are so many. There are so many that it makes sense that it's a lot of, it's interesting technology to be able to bring to you similar things. It doesn't look like a big deal if you are thinking in terms of just me, you, and the people you know. But every time you think about those tweets, know that it's, everybody is tweeting into the world, and for similar things to be able to come to you. So and then of course it's used in news headlines for people that aggregate news. How do you bring similar news together? And I should mention that for some of these foundational NLP tasks, there are usually those pre-made, there are usually those data sets that you use to practice to get good at it. They are literally labeled by actual people. We're not talking about data curation here, so I'm not going to mention that. But if you're going to be great at what you want to become, I don't know why you are part of these classes. You may be trying to improve, you may be trying to pivot careers, which makes sense. It always makes sense for you to be able to, if there are skill sets that you can learn that can change the tone of what you can aspire to, you should totally do them. So, but if you are going to do interesting work with the data at your workplace, you must figure out how to label data, how to measure the quality of the data. When you apply these NLP techniques, how to gauge if they're effective, the machine learning models that you're using, you must learn how to, if it's no longer working, what is the next thing to try, and things like that. So I just thought to mention that. Yes, there is summarizing. Yeah, then there is similarity. One of the practical use cases of this similarity is that on one of the work that a project that I've been part of where this was really important is we were so let's say you are curating data and two people are answering the same questions from the same document. The interesting thing about two people answering the same question from the same document is that both of them can be right, but they are selecting different parts of the document. So let's say it's a scientific publication. I could say my answer is from the abstract, but another person is choosing from paragraph 4. Our answers are similar, but they are not the same text. So we cannot just say that, oh, people who selected this span of data from span 2 to span 4, that they are the ones that are right. Because our goal is to see if there is a semantic agreement between those two people. Like semantic is typically tied to meaning. Like, are we saying the same thing even if we are using different words? It's such an interesting method. So you encode and then you compare. And what makes semantic similarity truly interesting is that if what we are trying to say are truly similar, even if the words are different, our score will be very close. Very interesting work. Very interesting. So sometimes that's one of the ways you use similarity. You're trying to get the quality of something. Two people are labeling the same data. They are selecting different parts. But very interesting. It makes sense for you to know how to do something like this too. And then for people who are doing anomaly detection, maybe you're looking for people. I know sometimes you can eyeball it. Maybe in your team, people are sending fraudulent emails. You can have some, I'm not saying that's what you should do, but you could have some emails that, they are confirmed as fraudulent. And then you do some form of semantic similarity that any email that the meaning is similar to what is this email, they are suspects, flag it. That's one of the ways to use this. Like, I think the meaning, even though they've changed the text, they've changed the address, flag it. Let's look at it for people in financial institutions. It may be useful for you to be able to find similarity in text data, or maybe someone is doxing, you're trying to find maybe some type of bot and things like that. So you can, obviously you may not know that now, but you can compare the meaning of words. You can compare them and see if there's similarity, if there's anomaly and things like that. Okay, so at the fundamental of everything related to NLP, all the things that I've mentioned before, this is it. ML algorithms cannot read raw text. They can't. So all the things, as I was typing into that chat window thing, it wasn't saying text. Somewhere in the back end, it was saying numbers. So every time you think about text data, ML algorithms, computer algorithms, they don't work directly with text. There's always, know that it's acting super fast because that thing answered me on time, the chat interface, but behind it, you have changed it to some form of numbers. It always happens to some form of vectors. There will always be that part where raw text has been changed to something else before you feed it to ML algorithm. And that's a core tenet. That's a core processing tenet in NLP. Even if you don't know any other thing about NLP, know that all the written text is being changed to some form of numbers or vector at the back end. It always does that. Whatever system you're applying, that's why I encourage you to be great at your work, to be able to find out and explain exactly what's going on. So if you did not figure out anything yet from this class, even if it's overwhelming, know that every time you see text data, speech data, even image data, everybody changes to some form of text, some form of numbers before they are processed. So I did the Shalaye here. Classifier, learning algorithms, generative algorithm, whatever type of algorithm, they cannot directly process text documents. So it expects them to be in some numerical, method. It could be just numbers, it could be vectors, and they should have sense in the sense that it should not be all over the place. So that means that behind every form of unstructured text, unstructured in terms of it's not placed in tables, there's also the structuring of the format. Algorithms expect them to come at least as a form of number. It may now be 0 and 1, no. It may be 1, 2, 3. It should come as a form of number. It could be vectors, or it could be matrices. Or so every text data, every other form of data, before they are processed, they usually change to some form of a number. Okay, you know what I like about this? This was in 2018. And so that you will know things about language models, they are not new. This author, it says, the process of transforming text into numeric stuff is usually performed by building a language model. So language models are not new. They're not what started happening maybe when you started hearing things like transformers and things like that. And these models typically assign probabilities, frequency, or some obscure numbers to words, sequences of words, group of words, section of documents, or whole document. So this is well written. Like whatever format you're using, words, you're using text, it could be few sentences, it could be paragraphs, it can be all documents, it can be a whole database, it will turn to number. Somewhere, there will be a preprocessing step that turn it to number. So there are different ways to represent text. And as you are thinking of it and all the problems that you think of, these are some of the popular ways. Of course, there may be others. In fact, there are others, but these are some of the most prominent that you will typically come across. So One-Hot Encoding, I think, so it's typically used for categorical variables, and it means that we are representing our data as As I'm teaching each of these ones, before I go to the pros and cons, I will appreciate if you are listing what you think may be a pro, which is a disadvantage, and what you think may be the con, which is a disadvantage of the method, before I now go there myself. So just pay attention to the ones that you can get. So some people thought that rather than the method we just finished, where we were encoding the alphabet directly, that can we create vectors for each thing? So we want to map them to 1 and 0. That means that, let's say we have a vector. That means that if a word exists, we'll put 1. If it does not exist, we will put 0. So let me show you how this works. This One-Hot encoding. So I should have used AI Saturday for this, but it's okay. This is a popular example. These are the owners. So if you look at how they encoded this sentence, they said the quick brown fox jumps over the lazy dog. So these are vectors. This vector now, when there is D, it's 1. Every other thing is 0. The vector is usually the length of the sentence. So now this sentence has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 tokens. Typically, this is English. There are some languages that, that's where NLP can get stressful. This is English, and for most languages that we speak, you can delimit by the empty spaces. But for some languages, you can't delimit by the empty spaces, and that's another topic on its own. How do you tokenize languages that are not directly that, the space does not necessarily mean that it's a separate token. But luckily for English and most languages we probably speak, you can split a sentence into this. So for this quick brown fox, if you look at what they did there, like I said, these are 9 tokens, which are 9 words. If there's a full stop here, it's a token on its own. Typically, you want to separate it that way. So let's count the vector 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. So what we are doing here, it looks a bit like abacus or something. See, so we said that. So for this data, that if you put 1, that means a word exists here. So here, D1 takes here, and we fill every other thing as 0. The quick is the second one. We put it here, and we fill every other thing as 0. Remember that I would like you to write what you think may be the disadvantage of this method in the chat window. If you have that, just, You are free to share what you think it is. If it's not what it is, I can always mention it. And then brown is the third one. So if you are looking, if we cross, okay, how do I don't have the pen. Okay, so if you're looking at this, you know that everywhere you found one, that means there was a token there. So let me look at what you think may be the disadvantage of this. Okay, Victor says the vector is 8 and not 9. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's true. Let me count this. 1, 2, 3, 4, 5, 6, 7, 8. This is interesting. So which of the vectors did we miss? Okay, D is mentioned twice. Thank you, Sarah. I didn't even think of that. Is it mentioned twice? Yes. 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 I didn't even look at that. Thank you. Lack of user context. It's true. Let me go back and read. I didn't even look at the D, but it's true. Victor, thank you for raising that. And Sarah is right. Sarah is very right. So everywhere we find D, we simply repeat the same vector, which is D at position 0. This thing is shaking. Okay, which is D at position 0. Yes, that means you are right. Sarah mentioned this first, so you are also right about that. Okay, someone said something interesting, and I'm trying to read it. Yes, reuse of vector. Yes, most systems allow you to reuse vectors anyway, in order to have a vector that can be a lot of storage. Yes, Usman, I like how everyone is raising this question of storage, because facing storage issues is not usually a big deal if you're working with sentences, but the moment your work scales, you will feel it. Your laptop will feel it. You will complain. Your manager will not come to your mercy. Okay. Yes, Usman, you're right. Let me see. Someone talked about lack of usage context. Olorundara, you're very right. In order to, yes. So thank you everyone for participating well. So we've seen some of the loopholes of this method. This method is more advanced, is better than what we did before. And typically in practice, I typically don't use word encoding, but you typically most times, if anyone is using it, you are using it to represent labels, because many times labels are not many. Most times you're probably working with just 3, or maybe no matter the challenge you're facing, many times maybe just 20 labels. So, but in practice, most people that use One-Hot Encoding, I don't know, maybe if you work in genetics or something, if it's limited and things like that, it may be useful. But there are now better methods. But this is another approach that people thought of. And all the concerns that you raised there, they are right. So it's simple and it's independent. I like the fact that you figured the repeated use of D out, because that's one of the thing of it being independent. You know, you can know that D is D, at least based on this One-Hot that you said. And some of the points that I raised are things that you've raised. It's not effective for large vocabularies. Someone talked about lack of context. It's true. There's no relationship between the words. It's just cruising. Yeah, someone mentioned that. And the third one, computational inefficiency. So the team figured out both the cons and the pros. Clap for yourselves. Let's go to the next one. So for this, there is n-gram. N here usually means N could mean words, it could mean sentences, but typically it's words or tokens. And then, so in this scenario, I can't mention my preference. So there is n-gram where you either tokenize by 1 token each, or you tokenize by 2 tokens each, or you tokenize by 3 tokens each. So let's look at n-gram. So this is an example of n-gram. N-gram is able to have a bit of context. For example, if you use this trigram now. It's even showing the complete sentences and can predict. If you train it well enough and you have enough samples, it's easier for you to predict the next word. But it's also bogus. It's useful in text generation. Have I used Ngram in anything recently? No. Even when I didn't have wings like this, I've always side-eyed it a bit. Okay, remove that. But what it does better than, let's say, something like One-Hot Encoding. Let me see if you can figure it out. How do you think this method is an improvement on the One-Hot Encoding? If you have a perspective, you can share in the chat window before I now share the pros and cons. Let me see if there's any feedback on that. Okay, so this is another approach that people tried. Grouping of text. Yes, Elijah, you are right. This bit of context means your machine learning model will learn that it's not in isolation, that, oh, you're not alone, or, you know, that words usually come after other things, because machine learning models are not as smart as people. You know, they're not as smart as people. And for them to be effective is how they are trained. Yes, it's able to encode a bit of context. It's able to encode a bit of context. I don't know if that context will now be dynamic, because many times if you use welcome in English, there will be you trying to welcome people to somewhere true. So many times if you train a system with bigrams or trigrams, you'll be able to predict better true, rather than the independent one-hot encoding. So let's see. So like Elijah said, there's grouping of text. Let me move this. So there's grouping of text, and then it's a bit sequential. It's not scattered. For example, the last time we talked about the fox that was jumping, you know, there was D twice. If you scatter those vectors, they are not able to exactly retain sequence if you don't arrange it yourself. And then and the varying length, you can capture. If, for example, if you want to train a model, you can train a model with both the unigram, the bigram, and the trigram, so that it can learn that, okay, you're not in isolation. The con is still like others. The data is sparse. If the data is sparse, there will be high dimensionality. We will have computation Wuraola. It's sensitive to other. If it doesn't follow what you arranged, it doesn't have sense like that. It just scatter. If it doesn't follow your sequence. And then though it captures a bit of semantics, but it's still limited. It's not as smart. And then people kept thinking. So the next method, well, I don't know if they are in parallel, but another method is bag of words. And the interesting thing about bag of words is that you can still use it in quite a number of things. It's not, when you talk to some people in practice and stuff like that, especially if you're, okay, don't let me go there yet. So what bag of words usually do is to bag of words, what you typically do is to put all your words in the bag, all the sentences. But what it does is that, let's say there's a text document now, and I was mentioning AI Saturday like a lot. While there may be other important things in the text, what bag of words is going to figure out is that the more you are, the more important you are. But that's not what it is. For the mere fact that there's a bag with so many yellow balls or something, it doesn't suddenly, yellow balls may be important, but it doesn't make them the most important. But that's how bag of words interpret it. So if you're talking, sure, this is the fundamental for, let's say you've done some NLP task and they ask you to remove stop words like the, or this is where it's based on, because stop words can be common in a sentence, but they don't have anything to do with the meaning. They are there as joiners. So this is where it's based on, to remove stop words and, just try to shrink your text to the most important. And then, of course, you remove stop words too, to reduce computational cost and things like that, that anything that is too repeated, let's remove it. So it's simple. Interestingly, like I said, it can be efficient. despite the fact that it probably will not capture the context and things like that. If your data set is large enough, you're in a hurry, you don't have time, you want a very simple system, bag of words still work, but they don't have sequence order because all the words, they've chopped them into tokens, they just put them in the same bag. And then it speaks length representation. What this means is that if a word is not in that bag that you did, with the expense, if the model you created is based on limited text, that means that whatever you want to do should be in the scope of that data alone. What about other data sets? Do you always have to train from scratch? So this is where the Wuraola is. And then, of course, it also has high dimensionality. It's still a lot. So temp frequency inverse document frequency is like an improvement on bag of words. What this aims to solve is that it's tried to, while this word is plenty in this text, true, like let me speak it in Nigerian, is it really important? It was trying to solve for the problem of, we understand that a word may have recorded through a body of text like a lot, but we want to assign a weight to it. Like, does it really make sense? Like, what if it's a lot? If it's recurrent, does it really make sense? And then because of this, because there's the form of penalty for words that apply the lot, and if they don't make sense over a document, there's better weights for rare words. So words that are important, but not many, they get to have more representation with TF-IDF. But TF-IDF is in relation to an entire, it's not really useful for single documents. It's mostly like it expects a lot of document, and then it will weigh whatever token, whatever words across a big document. So if you have single documents, it may not be your, but another approach typically is that you use the two. You use bag of word, you use TF-IDF. You train your model on the two. Sometimes it's the bag of word that will, behave better on your data set. But typically as a data scientist, it makes sense for you to try at least two different types to even see what each one is saying. So sometimes on your data set, despite the fact that bag of word has its fault, it's just going to be the better performing one. So the answer to that is for you to try more than one. As a scientist, don't just be the person that you just try one method. It makes sense for you to try different methods, try it and fail, try it and fix your code error. Don't run away. Don't do this thing, or they did not teach us this method, I'm not going to think of other things. So like I said, it weighs word relevance and it penalizes common words. So sometimes if you're using TF-IDF, most of the code for bag of words, TF-IDF, they are usually, most of them are in sklearn already. Sklearn is a popular machine learning library. And even, let's say you are doing something like topic modeling, something like Jensen, there are usually options for you. Do you want to remove the stop words? Many of them are already in code that you use often. It just makes sense for you to understand how they work. So it ignores sequence order. Interestingly, as much as Ngram is simpler, Ngram pays attention to word order. It does, as much as it's not as advanced in code. The TF-IDF bag of word does not understand semantic understanding. What semantic understanding means is that, let's say, I'm going to use this statement, there is a bank on the river bank. There is bank twice there, meaning different things. TF-IDF, bag of words, all these other systems, they don't used to have sense that they are different. They will just say bank is bank, even if they mean different things. Imagine if you're not applying them to a tonal language like maybe Yoruba, where similar spelling, I think many Nigerian languages can be like that, where similar spellings look for the same word. It's to just say all of them, they are the same thing. That's why to teach your model. That bank is bank, and then, so no semantic. So that's where the research kept going for that. Like, we've not been able to figure this out. Our model does not know this thing. It will just lump all of them in the same bag, in the same time frequency and things like that. So if you want a bit of semantic and contextual understanding, like we mentioned from the beginning, which is a key goal in NLP, it's still limited with TF-IDF. But why it's still in use, bag of what TF-IDF, sometimes you don't want something complicated for your data. And like I said, many times if you have enough representation and things like that, it truly just works, that you don't need to go overboard. Like it just works. It doesn't have to be the most difficult algorithms that work best. So now we've gotten to embedding. And why embedding is superior to all other methods is that this is the first time we figured out how to add contextual meaning to our encoding. And the simplest way to talk about embedding is like creating a network. You know, someone mentioned the ASCII table at the beginning of this. I've not used the ASCII table for anything, but what embedding does is that, you know, we've mentioned that we have a problem of trying to encode the meaning of a word. Behind the system of word encoding and word embedding, there is something called a word is known by the company that it keeps. So that means that words that are similar in meaning, words that are similar in use, even if their spelling is the same, if you expose your algorithm to a big enough data set, words will be close to what they are related to. Like, so the bank that is a financial institution will be close to financial words, and the bank of a river that is close to river will be close to nature. So it's like you created, what embedding aim to solve is that rather than doing your own ABC like we did at the beginning of this, or doing your own encoding, we did Word2Vec, GLOW, fast text. What we decided to do in quotes is that we created our own ecosystem of model. Like we trained on different data sets that it's like, so now when you query for the bank, or the bank that is a financial institution, it will have a different vector to the bank that is of river. And this bank that is a financial institution will be close to financial words, that the vector encoding, just like that encoding that we, the vector that we had for when we were jumping, the fox that was jumping in the initial one. So each word, and then it will be reproducible. So that means if you're using any of this word embedding, all the words, it's like a vector database. I'm not going to call it vector database, but it's exactly like that, such that if I'm working with any of these models wherever I am, based on what I'm training, the encoding will be similar to what you will get wherever you are. So we brought in a bit of stability that solves all the question of, should our 1 and 9, what if it's close to 19? What if this one is double words? So this one, it's like, there are tiny, and then of course, it depends on the language. And then of course, you can fine tune them to your own task. So that means that for some of these pre-trained models, you can create your own ecosystem with this Word2Vec. There is sentence-to-vec to where you want to encode our sentences. I use that. Yeah, so there is sentence-to-vec to where you want to encode your sentences as, vectors. So you can fine-tune this, but then it solves the problem of, so behind this technology, like I said, that you should know that a word is close to the company it keeps. That's how it's able to figure out, sometimes people use this for, tasks like words and opposites. Like they could say man is to woman, king, it will figure out that it's queen. It can figure out things like that. Of course, there are now things that are biased about this system. Those are the questions around when you're designing things like this. You want it to be ethical. You don't want to just say, this thing that we've trained, this is how it used to work, we won't improve. I downloaded it like that. You have a responsibility not to encode nonsense into the world. So this is the closest definition to embedding that I can give to you. That means that with an embedding, So you can download a pre-trained one based on a particular data set and use it in your work. So rather than doing that matching one by one, it can simply extract the pre-trained vectors and use them. So let me go to the next one. So some of the pros, semantic and contextual representation, pre-trained embeddings. And pre-trained embeddings is valuable, especially when you are working in a low resource system, which you probably will, which you should probably learn how to work anyway. It's nice to be able to leverage on the work of others. It now comes with its own Wuraola. Like, let's say they've encoded a wicked thing into the pre-trained embedding, it will come to your work. So it makes sense for you to know how to train yours. And it makes sense for you as a scientist to try out what exists and build on it. So what can, okay, I already came to show this. I will have asked you to answer, but maybe you can find more. These are some of the pros that I'm thinking of this word embedding, and these are some of the cons. If you have more apart from what is on screen, you can share. So out of word vocabulary. So now we've created this ecosystem. What if the word you want to use is not in that embedding, which happens, is not far, because embedding is not, okay, don't let me sound too Nigerian here. I want to say embedding is not an all-knowing oracle or something. But there are usually out of vocabulary words. So sometimes the word that you want will not have a representation in that embedding. And then it speaks context. That means that whatever you are doing is built or whatever embedding you choose. But when this happens, I'm saying when this happens because I believe you're becoming a professional at this. Some of you will lead teams, some of you will be part of research. The answer is usually to train yours from scratch. I want you to be confident to be able to try to train something from scratch, not just what is pre-trained alone. So you can start from what is pre-trained. If it doesn't answer your question, I want you to have the confidence to read the paper, give it a shot, keep answering questions till you can train on your own data set. And then sometimes there is the thing of data restriction. Again, like I said, sometimes the system you're working with, they don't just want any form of interaction with outside things. But it's pretty cool how the problem of context was finally solved, because this led on to greater things. And now the most interesting part of state of the art, we started a part of this lesson with, we looking up some things on ChatGPT, and then behind it, the algorithm that powers it's called transformers. And how is transformers better than embedding? We started a journey from where we were trying to just match numbers with alphabet and things like that. And now we are transformers. And we didn't have this the last time I taught this class. So what transformer does is it's close to how embedding works, but it has something called the attention mechanism that lets it know what to remember and what to forget, in quotes. Many algorithms that you work with, let's say you even work with recurrent neural networks, they used to forget things. That's where long short-term memory is an improvement on RNN. But transformers have the capacity to figure out that they bank on the bank of the river, the important things. And of course, attention mechanism is math. It's, matrix multiplication and things like that. So it's able to capture context more efficiently. And it's another thing that it does well is that it's able to, so some of the pros is state-of-the-art performance. It's interesting that, of course, there are different types of, oh, sorry about this. Of course, there are different types of models, but then you can, with transformers, you can do transfer learning with embedding too, but you can do transfer learning with transformers. There's multilingual support where so many data, some of them, so the data that is used to train many of them is truly big. So it has big coverage. It will probably have some answer to your question. And of course, some of the con is it's computationally intense. There are ethical concerns around it hallucinating. Like I was asking question, it could sometimes produce an answer and call it as fact. Of course, there's a lot of improvement saying that its training stopped at 2021. That's a good context. That's where the internet scroll or whatever it's used was used to train. It's good we are mentioning that. And of course, there are many other systems to try. Yeah. So let me go to this part. So typically when you're working with text, interestingly, when you're working with things like transformers, embedding, you used to have to stress like this. I won't call this stress. If you're working with NLP, you should be able to pre-process your own data. Sometimes remove numbers. Sometimes I talk about, sometimes you want to remove single words until you're working with clinical data or maybe some chemistry data, and the number is important. Like if I write potassium as K, if I say this thing, remove all the single words, it's going to remove that information. So many of these preprocessing text, sometimes if the data is from the web, you want to remove the HTML tag, you want to remove the extra white spaces. These things that we do here, most of the processes that you do here, convert accented characters to ASCII, which is more standardized, is to reduce that Wuraola of computation. I know somebody mentioned what if large numbers and capital and smaller words. Many times you want to lower all your text cases so they all look the same. Remove special characters. Sometimes you don't always want to do that. But I think the cool thing about pre-trained models, pre-trained embeddings, that sometimes, many times you don't have to pre-process your data this deeply. There's lemmatization where what you attempt to do at lemmatization and what's the twin of lemmatization? There's another method of what you want to do is that if a word is give, giving, gave, you want to lemmatize all of them back to give. So that these are all the things people attempt to do to reduce computational space, because it's a big problem. It's not a big problem when you're working with a small data set, but like I said, when you're thinking of all these use cases, I want you to think of them in terms of scale, like what you are facing, what you need to pre-process, what you need to do. It's not, if it's something that you can just eyeball, that you don't have to think about, there is no need for NLP. But when you have large data sets, some people will probably be working with languages, you are working with large crawl, whatever you end up doing, some of them you can plan, some of them you can't plan. But these are some of the reasons why people, when you do all this pre-processing, you're just trying to increase your chances at success. An interesting task you may try is you can read up text pre-processing, some of the things you can do. You can attempt to train a model where you did not remove all this, and then train another model where you attempted to remove this. That's how to be a good ML engineer, is by trying. They say we should lower all cases. Me, I don't want to lower my cases. What will happen? Find out what happens. They say we should remove accented characters. I don't want to remove mine. Find out what happens. That's how to become good at this. They say we should remove stop words. Sometimes I don't want to remove stop words. Sometimes you don't want to remove numbers. So why are they asking me to do all this?